Hi, this video will help you review all of the major concepts on the Pre-Algebra Advanced Unit 5 Formative 1. First, you need to know the difference between complementary angles and supplementary angles. Complementary angles are two angles that add up to 90 degrees, and supplementary angles are two angles that add up to 180 degrees. There are a couple ways to remember the difference between these. The first one is thinking of it alphabetically. Complementary comes before supplementary, therefore it's a less than. Supplementary, or S, comes after C, so therefore it would be bigger. Or you can remember that if you start with a C, you can turn that into a 9. Or if you have an S for supplementary, you could add that, or you could add to it and make an 8 for 180. So you would have a C that turns into a 9 for 90, and then an S that turns into an 8 for 180.
Why do you have to make those?
Take a look at these 4 angle relationships that will help you find and prove angle measures. All of these highlighted angle relationships mean that they have equivalent or congruent angle measures. The first one is corresponding angles, and corresponding means that they sit in the same position. This is an example of corresponding angles right there. The second one to the right is alternate interior angles. Alternate interior angles are two angles on the inside of two parallel lines, and they are opposite of the transversal. Next we have vertical angles. Vertical angles are two angles that sit across from each other when two lines intersect. And then we have alternate exterior angles. Those are two angles on the outside, or the exterior, of two parallel lines cut by a transversal. Again, remember that all of these have two angles with congruent measures. These angle relationships prove very helpful when determining angle measures when only given a small amount of information. For example, if they give you that the measure of angle 1 is 70 degrees, you can figure out every single angle on this image. To start, angle 2. I can see that angle 2 is adjacent to angle 1. Also, when you put those together, they create a straight line, which is supplementary angles. So I know that the measure of angle 2 is 110 degrees because angle 1 and angle 2 are supplementary. I'm going to abbreviate that for you. Then I could look at angle 3, and I can see that angle 3 is across from angle 1, which makes them vertical, and vertical angles are equivalent. So I know that angle 3 is 70 degrees because angle 1 and angle 3 are vertical. Then I can look at angle number 5, and I can see that that sits in the same position, which makes it a corresponding angle. And corresponding angles have the same measure. So angle 5 is also 70 degrees because angle 1 and angle 5 are corresponding. You could also at that point say that angle 3 and angle 5 are alternate interior angles, which also have the same measure. Either one of those justifications will work. You can continue to do that for the rest of the angles on this figure. Angle 11, if you look at that in comparison to angle 5, you can see that that also sits in the same position. So you could say that angle 1 and angle 11 are corresponding, or you could say that angle 11 and angle 5 are corresponding, which in turn gives them congruent measures. So angle 11 is also 70 degrees. From there, you could say that angle 12 and angle 11 are supplementary because they add up to make 180. Therefore, 112 is 110 degrees. And then you could jump to angle 16, which you could say is alternate exterior to angle 3. You could say that it's corresponding to angle 1. You could say that it is corresponding to angle 11. You can use any of those justifications as long as they are accurate. You will be expected to classify the different types of triangles. You will also be expected to be able to draw them. Take note of how you prove how many equivalent sides you have by using those indicators on the sides. And also notice the angles. If they ask you for a scalene right triangle, that would mean that you would need to draw an angle with all different sides, with one angle measure being 90. And for example, you could draw a triangle that looks like this. It would be scalene, so all sides would be different. And you show that by not having any of the same number of marks on those sides. And then you would also want to show in there that one of your angles is a right angle. Also, remember what it means to be a regular polygon. A regular polygon is a polygon with all equivalent sides and all equivalent angles. So the one regular polygon that is a triangle is your equilateral triangle. All your sides are the same and all of your angles are the same. This is kind of like a puzzle, and these are fun. Try to remember all of the different rules that you know, and then you can solve for all of these different angle measures that are missing. The first one that I am going to start with is one that jumps out at me up here. Angle A is across from, or it's a vertical angle from 60. So I know that angle A is 60 degrees. Now, if I look down here, I can see that I have three angles here that add up to be 180. I'm missing this piece right here, but I know that the other two are 110 and 51, which is 161. So in order to add up to be 180, I know that angle B has to be 19 degrees. Now, angle A, B, and C inside of that triangle I know have to add up to be 180. So if I have 79 degrees, in order to add up to be the total of 180, which is the interior angles of every single triangle, again, 60 plus 19 is 79. So I would know that angle C has to be 101 degrees. Now, since angle C is 101, I know that together with angle D, that is also supplementary because it creates a straight line. So I know that angle D is 79 degrees. Now, to find angle E, I have two of those angles in a triangle, so now I can find the third. If I take 79 and add that to 51, that gives me a total of 130. So therefore, in order for this to add up to be 180, angle E has to be 50 degrees. Find a place to start and keep working using all of your angle relationships and rules until you can find all of those missing angles. The following part of this video will help you prepare for the Unit 5 summative assessment. Please make sure you know the difference between complementary and supplementary angles. The biggest thing to keep in mind about both of those is that complementary angles are two angles that add up to 90, and supplementary angles are angles that add up to 180. So complementary angles, when you put them together, create a perfect square corner, and supplementary angles together create a straight line. There's a square corner and then your straight line. Now, you may be asked several different questions, regarding complementary and supplementary angles, but the big thing, to know is that complementary is two things put together that equal 90, and supplementary are two angles put together that equal 180. Remember in math that whenever you don't know something, you always refer to it in terms of a variable. So if you wanted to know two angles that add up to 90, you don't really know the measure of these individual angles right here, but when you put them together, when we put two things together in math, that's shown by addition. So the mathematical way to show this would be, angle ABC plus angle CBD. When you add those together, you get a total of 90. Or, you can keep it simple and just call it x plus y. When you put two things together, it equals 90. Same thing would go with supplementary angles. You're adding two angles that you don't know. They are unknown. So maybe perhaps you want to call that A and B. So maybe A plus B equals 180. It is going to be very important that you know the vocabulary for this unit. And most of those vocabulary terms are associated with types of angles. So I'm talking about adjacent angles, complementary angles, supplementary angles, alternate interior angles, vertical angles, all of those angle relationships that we've talked about. You may be asked to give an example of a certain type of angle. So for example, maybe we're talking about adjacent angles. Maybe we're talking about angles that are adjacent to angle BPC. Well, adjacent angles are two angles that are next to that. They have to share a side and a vertex. So one angle that is next to that or adjacent would be angle APB. And remember that we indicate angles with the less than sign in front. That's the angle notation. So that would be angle APB. And remember that the vertex of an angle always goes in the middle. Another angle that is adjacent to this, again, it must share a side and have a common vertex. So there you are talking about angle CP, and there isn't another letter here, so I'm going to make it up and call it Y. So that would be CPY. Please make sure that you are using proper notation. You will be counted off if you don't label angles and line segments correctly. For example, another type of vocabulary word that you would have to know is something like alternate exterior angles. Exterior means on the outside, so you are talking about two angles that are on the outside of parallel lines. And then opposite means on the other side. So outside of the parallel lines would be on the top and bottom of these two parallel lines. And then on the opposite sides of this transversal would be one on the left and one on the right. So alternate exterior angles would be angle 1 and angle 7. Or maybe we're talking about vertical angles. Vertical angles are two angles that are directly across from each other. They are formed by two intersecting lines. So if I'm talking about angle 2, the angle vertical from that would be angle 4. Make sure, again, that you know how to find examples of all of those types of angles we've studied in this unit. Refer to your Quizlet link if you are unsure of all of those different types of angles and angle relationships that we have studied. Last but not least, please make sure that you know all of the different figures that we have studied this unit. For example, you need to know all of the different types of triangles, and they are named based on their sides and angles. So for example, if it has these markings, it means that none of the sides are the same and none of the angles are the same. So this would be an acute scalene triangle. On the flip side, you might have something that looks like this. You name it based on the sides and the angles. Since this has two angles that are the same, this would be a right isosceles triangle, named for its angles and its sides. And remember, whenever you have to label these, you want to make sure that they are named according to their vertices. Then we also talked about different types of polygons, all of the different types of quadrilaterals. For example, the difference between a rectangle and a square. The difference between those two is that a rectangle has two pairs of parallel sides and opposite sides that are congruent. A square has 4 90-degree angles and 4 congruent sides. There's that one piece that makes them different. We also talk about trapezoids. Trapezoids have one pair of parallel sides. And then we also talked about regular polygons, and regular polygons have all angles and all sides the same. So a regular pentagon, you would have to show, that is a terrible pentagon, I am sorry, but you would show with your markings that all of the sides are the same, and then you would show with your angle markings that all of those angles are also the same or congruent. So for example, if you were asked to draw an equilateral triangle, it's not like I am going to take out a ruler and measure, but what I'm going to look for is that you have a triangle that looks like the sides are about the same, but you show that in the markings. Equilateral means that all sides are the same, so you would indicate it with one mark on each side, which also means that all of those angles are the same, so you would show that as well. And remember, it'll probably say something like, draw a triangle ABC that is equilateral. So make sure that you label those vertices. All right, that's all I got. Good luck. And as always, good luck.